So we're going to do some examples of sketching space curves. Now, if I have some R function that defines the vector over time, then what I can think about is each of these components as a single function, and I can plot how they vary over time. And that will give me the coordinates that I can plot on a graph to see if I can construct the graph correctly. So let's start here. I have ti, 2t minus 5j, and 3tk. Now, I'm going to pick some simple numbers. We probably should also pick some negative numbers, but for this case, we're not going to do that. So we'll start at t equals 0. Now, to do that, when t is 0, the x component is also 0. And the y component is 0 minus 5, and the z component is 3 times 0, which is also 0. When t is 1, we have 1. 2 minus 5 is negative 3. 3 times 1 is 3. 2. 4 minus 5. 3 times 2 is 6. And then 3. 6 minus 5 is 1. And 3 times 3 is 9. So we have our first order triplet is 0, negative 5, 0. So if I say 0 on the x, say negative 5 on the y, and 0 on the z. So we're actually on the y-axis here. And then my next point, 1, negative 3, 3. So I would come out 1 here. So let's draw some dots so we can kind of keep track of this. Draw 1, negative 3, and then up 3. So that gets us our next point, which is here. And then we have 2, negative 1, 6. So we go out 2. And then we're only going in negative 1. And then we're going up 6. So we went 3 here, so we're going to go 3, 6. And then finally we have 3, 1, 9. So we go out 3. And then we go positive 1. And then we go positive 9. So if that's 3, then that's 6, 3, 6, 9, up around here. What we have is pretty much a straight line through. So that one's not perfect, but the idea is it's kind of coming out of the board. You know, maybe in another thought, I might have rotated the axis a little bit, and that's going to give us a better view of that. But in general, the idea here is you just plot these points over time. Now, this one's a little more interesting, so let's get to it. Now, when t is 0, x is 0, 3 times cosine of 0, so cosine of 0 is 1. So 3 times 1 is 3. Sine of 0 is 0. So then that's pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So 3 times that is 3. At pi, we are there. Cosine is negative 1. So that's negative 3. And then that's 0. And then this is 3 pi over 2. Cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1, so we have negative 3. So what we see is the x value is continuing to go, is continuing to increase here, but the y and z value are alternating. They're going back and forth between 0, 3, and negative 3. sorry, that's, yeah, so that's going to be 3. So if you define these as your negative and positive 3's, really should have done that in black. Then we have 0, 3, 0. So what that gets us is 0. So our starting value is here with the blue. Doesn't really look that blue because of what I've done. It's maybe there. And then x goes to pi over 2. So that's a little bigger than 1.5. So whatever that is, we come out to about half of that here. And then y is 0, but now z is positive 3. So we start here and we go up. And then x comes out to pi, which is a little bigger than 3, so you're all the way out here. And then y goes all the way to negative 3, so we're out here. And then we have 3 pi over 2, which is a little bigger than 4.5. So you're kind of out here. But z is now at negative 3, so you're down here. So what you find is you're creating this corkscrew or helix. And if you think about that, it makes a ton of sense. Because this right here, if we were just plotting those two, that's going to form a circle. So if I were looking directly down the barrel of that x-axis, I would just see a projected circle. But the x value is increasing, so you can think of it almost like a slinky. If you look at a slinky straight up, it's circular, but if you start to pull it, it forms this type of situation. And the coefficient that would be here tells you whether or not you have a really long slinky or whether or not you have a very compacted slinky. And so that makes sense because if that value were to shrink towards 0, these would compress on top of itself. And then if this ever got to be actually 0, you would actually only have a circle. And so those are some examples of plotting space curves.